Okay, moving on. We're going to continue our topic of slope. So we're looking at finding the slope of a given line using 2 points off the line. So we talked about slope being the rise and run between 2 points on a line. So your vertical distance traveled over your horizontal distance, the change in y over change in x. Well, we want to carry that over now into functions. As we look at functions, we can find an average rate of change between 2 points, right, on that particular function. So from point 1 to point 2, right, the average rate of change would be the slope of the line passing through those 2 points for that given function. So we're calculating slope, and we're calculating the average rate of change for a given function. So here in this example, you can see that we're looking at the graph of a function over here on the side. With that said, in part A, it wants us to find the average rate of change from x equals 0 to x equal to 3. So let's go ahead and look at that here on our graph. All right, at x equals 0, so again, here's 0 on the x-axis. Right, we have this point, 0, 2. And then we're going over to x equals 3. Here's 3 on the x-axis. And as we meet up with this graph here, we've got right here the point 39, right, on this graph. So now we've got our 2 points. So what would be the average rate of change, right, from point 1 to point 2? What would be the slope of the line, right, passing through? Well, we can draw that in here, the slope of the line passing through those 2 points. So we can draw a quick sketch of that line. We want to find the slope, right, of that line there passing through those 2 points. That would be our average rate of change. All right, so let's go ahead and do that. So we understand slope. So M is equal to change in y over change in x. So if we're going from x equals 0 to x equals 3, right, we see the y values, right? We got 9 and 2. So again, y2 minus y1 over x2 minus x1. So we got 9 minus 2 divided by 3 minus 0. As we simplify, we get 7 over 3. So here's our average rate of change, right? Here's the arc. All right, there's the average rate of change. So average rate of change is the slope of the line passing through those 2 points. All right, moving on. And again, I'll draw that line back in there. All right, we're looking at that line. Let's go on to example B. Now, with the same function, we want to go from, I'll do this one in blue, from x equal 1 to x equal to 2. So let's go ahead and highlight those 2 points. So we're looking at the point, 1, 3. And we're going over here to 2. And that would be the point 2, 5. Right? You wanted to draw a line, right, passing through those 2 points. So we're trying to find the slope of. So again, the average rate of change, right, would equal the slope. So y2 minus y1 over x2 minus x1. So we have y values of 5 and 3. 5 minus 3 are the function values at x equal 1, x equal 2. And the x value is 2 minus 1. And as we simplify down, we get 2 over 1 or 2. So our average rate of change is 2, right? Up 2, right 1, up 2, right 1. That's our slope value. That's the slope of the line passing through those 2 points on that function. All right, now moving on to our next example. We want to find the average rate of change for the given function. This time they give us a function f of x, and you notice it's a linear function. All right, with that said, with a linear function, right, slope intercept form in front of us, right, should be -3 for our average rate of change, but let's show that from our definition. So from x equal 9 to x equal 14, we're going to find the average rate of change. So arc is our slope. Now to find our y values, right, we're going to find f of 14, right, minus f of 9. Those will be the y values divided by the change in the x coordinates. So again, y2, right, minus y1 right, the numerator, and divided by x2 minus x1 here in the denominator. And if we want, we can put that here in a different color. All right, so I'm going to highlight that. All right, now with that said, as we're looking at this and we're trying to calculate the slope, let's go ahead and simplify down. Now, what is f of 14? So let's go ahead and find the corresponding y value. So I'm going to go down here to the side. Let's do the valuation. So what is f of 14, which again is going to be the y value at a input of x equal 14. So 7 minus 3x, 7 minus 3 times 14. So as we simplify that down, right, we have 7 minus 3 times 14, well, we get what, 42? And then 7 minus 42, we get a negative 35. So there's its y coordinate. So that implies a point, right, of 14, negative 35. For its y value. So there's that order pair, right? So there's that x and y value. There's our point, all right, that we're looking at. Now let's go ahead and find the other y value. So let's go ahead and calculate it. So with that, we got f of 9. F of 9 is equal to 7 minus 3 times 9. Well, that simplifies down to 7 minus 27, which is negative 20. There's its y coordinate. So we're looking at the order pair of 9, negative 20. So back to what we're needing, there are those y values, right? There's y2, right, and y1. You want to label them. There are 2 points that we're looking at. So back to our average rate of change, the slope. So f of 14, that gave us a value of negative 35, minus f of 9, which had a value of negative 20. So there's the difference in the y coordinates for those given points. And the x coordinates, of course, we got 9 minus 14 in the denominator. So we subtract the x coordinates. So as we simplify down, we know negative 35 minus a negative 20, well, ends up being a positive 20 as we subtract the negative. So I have negative 15 here in the numerator. 9 minus 14 is negative 5. And as we simplify that down, right, we've got a value of 3, right, as we simplify that down there. So let's, again, check these numbers, make sure we got everything plugged in correctly, right, as we were looking at these function values, right, for our problem. Now, with that said, as we did this, right, what do we have here in the denominator? Be careful. Check me. For some reason I've got this written backwards here. All right, we got 14 minus 9. I had 9 minus 14. So this ended up being a negative 5. So there's my mistake. But we simplified down to, what, negative 3. Which, again, we knew before we began, right, that was going to be the slope of this line because it was a linear function, right? It was in slope-intercept form, right? We got our x term and our constant term. Coefficient of x, right, is this value of the slope, and y-intercept location, and it's 7. That's our b value. But that is our arc. So, again, that's given a linear function. Well, let's change it up a little bit. Let's go to a quadratic function. In our next example, let's find the average rate of change of the given function, f of x equal to 7x squared minus 3x plus 2 from x equal to negative 1, x equal 2. So as we calculate the average rate of change, we go to finding our y values, right? y2 minus y1 or x2 minus x1. Well, we need to find the value of f with input of 2. Be the y value for x equal 2. Minus f of negative 1. We'll find our y value for x equal negative 1. Divided by 2 minus negative 1, the change in the x's. So again, there's y2, right, minus y1 over x2 minus x1. At our slope definition. Now, what is f of 2? Let's go ahead and find these corresponding y values. So I got 7 times 2 squared. Minus 3 times 2 plus 2. And as I simplify that, I got 7 times 4 minus 6 plus 2. So I got 28 minus 6 plus 2. 28 minus 6 is 22. 22 plus 2 is 24. So there's our value, right? F of 2 is equal to 24. So there's its y value. So there's that ordered pair of 2, 24. So again, if I want to label that point, that would be my second point. So there's that x2, y2 ordered pair. And then we'll go do the same thing as I find out what f of negative 1 is. That'd be 7 times negative 1 squared minus 3 times negative 1 plus 2. As I simplify, that's 7 times 1 minus 3 times negative 1 is plus 3 plus 2. So I got 7 plus 3 plus 2, which is equal to 12. So we got a value of 12 there. So there's that y coordinate, right, for that input of negative 1. So f of negative 1 is 12, which means we have the ordered pair of negative 1, 12 on the graph of this function. So there's that first point, x1, y1. We're going to label it. And back to our problem, slope, y2 minus y1, we got 24 minus 12. There's the difference in the y coordinates, right, our rise factor, our vertical distance from point 1 to point 2, divided by the change in x. So we're looking at 2 minus negative 1 as we extract the x value. 24 minus 12 is 12. 2 minus negative 1 is 2 plus 1, or 3. 12 divided by 3 is 4. So the average rate of change from x equal to negative 1 to x equal 2 on this quadratic function is 4. Got one more. Let's find the average rate of change of f of x equal 12 over x from x equal to negative 4 to x equals 6. So on this one, again, the arc or average rate of change equals what? F of 6 minus f of negative 4 divided by 6 minus negative 4. y2 minus y1 or x2 minus x1. So we got to calculate those y values. So what is f of 6? So f of x is 12 over x. F of 6 is 12 over 6, which simplifies to 2. And that gives me my y coordinate. So that implies we have the point of 6, 2. All right, so again, 6, 2. So there's our y coordinate that we're looking for. All right, and we label that, but there's point, I'll call that point 2, x2, y2. And now let's go do the same thing with our second value. We got f of negative 4 to calculate. F of negative 4 is 12 divided by negative 4. Right, out goes x, in comes negative 4. And we simplify, get negative 3, which again is our y coordinate. So that implies we have the point negative 4, negative 3. That's what I call them point 1, x1, y1, right, for its function value. So back to our slope definition, the average rate of change from x equal negative 4 to x equals 6. Our y2 minus y1 is 2 minus negative 3. And those function values we calculated over on the side. And then the x coordinates, we got 6 minus negative 4, of course, in the denominator. 2 minus negative 3 is 2 plus 3, or 5. 6 minus negative 4 is 6 plus 4, or 10. As we reduce, we get what? 1/2 as we divide out our common factor of 5. So my average rate of change is 1/2 for this function from x equal negative 4, right, to x equal 6. There's the arc, right, on that one. And let's finish it out. We got one more example. Let's move on to the next one with average rate of change. So to finish this set, it says Hayden launches a rocket straight up into the air. The table below gives the height of the rocket in meters at a few times in seconds during its flight. So we got, what, 1, 2, 3, 4, basically 5 data points, right? Input, the time, the x would be time in this one, and the output. So again, if you wanted to label these, right, x and y are variables, right? We're looking at the height of this rocket, which is a function of time. Right, so we have at 0 seconds, of course, the height is 0 meters. It hadn't left the ground yet. You can see in our second data point, we have a time of 2.2 seconds in flight in the air, and its height was 110 meters. 6.6 seconds, 198 meters, 8.8, 44 meters, 13.2, we're back on the ground again. Now it says find the average rate of change for this function, right? This is a function. It's a function of time, the height of this rocket, right? From 0 to 6.66. So there's our what? X values. So we're looking at these two data points in part A. So let's go ahead and find the average rate of change, the arc. So that would be, again, my function value, right, which again is looking at these 2 points. Here is our first point. We got our x1 and y1. And we got here is our second data point. Here's x2 and y2. So again, average rate of change is your slope of the line passing through those 2 points. So we've got all the values already calculated based off the table. So y2, which is 198, minus y1, which is 0, divided by x2, 6.6, minus x1. So we simplify down. And I got 198, right, divided by 6.6. Well, what is 199 or 198 divided by 6.6? Well, as we divide by that, we get 30. So we can simplify that down. That's 30. So there it is, 30 meters per second. There's our average rate of change, right? So 30 meters for every 1 second. That's our average rate of change of the height of the rocket from 0 to 6.6 seconds. Changing it up to our next example, we'll do this one in a different color, do it in blue. It says find the average rate of the change for the height of the rocket from 8.8 to 13.2. Well, again, we've got that up here. We can circle those 2 data points here in blue. So we got our x coordinate and our y coordinate, right? Time represents x, height's y. Here's our second point. We got x2 and y2. We want to label that. So again, our average rate of change, right, as we find the slope of the line passing through these 2 points, these 2 data points. Again, we've got our y values already calculated, y2 minus y1 over x2 minus x1. So we got 0 minus 44 as we subtract the y coordinates, divided by the change in the x coordinates. We got 13.2 minus 8.8, right, as we simplify that down. So as we're looking at it, we got negative 44 here in the numerator. And we got to do 13.2 minus 8.8. So go ahead and find the difference in those. So as we subtract those 2 values, what is 13.2 minus 8.8? I get 4.4. All right, now what's negative 44 divided by 4.4? I get 10, right? So that's negative 10. So again, negative 10 here. So with that said, this is negative 10 meters per second. All right, which means what? It's decreasing, right? It's decreasing in height here on this interval. So you can see an example where it's increasing in height over a given interval, where it's going up, this rocket. In our first example, we want to make note of that, we can, increasing in height on this interval. And then we see an interval, x values, where it's decreasing in height. So again, a basic application of average rate of change. All right, so I hope that helps you with average rate of change. We have one more topic, the difference quotient. We'll take a break and continue with those.